In this video, there are three goals. The first one is to define dimensional analysis and use conversion factors to convert between different units. Second goal is to use a unit prefix table to write relationships. And the third goal is to use dimensional analysis to convert between units with prefixes. Dimensional analysis is a method of analyzing units in order to convert to a desired unit. We've been doing this a little bit with different units, and hopefully you'll understand this example right here. It says to administer digoxin, a prescription drug, 0.5 milligrams intravenously daily. This one you don't really need to worry about. It's not pertinent to the problem, but this might be what a doctor orders, and you as a health professional may need to carry out this order. So what do? Well, you check the pharmacy. Now the drug concentration available from the pharmacy is digoxin 0.05 milligrams per milliliters. The question is, how many milliliters will you need to administer a 0.5 milligram dose? Okay, so this is what the actual drug looks like, and again, it's 0.05 milligrams per milliliter. How do you solve this problem? Okay, well, what you're going to need to do is to write down a relationship, because in order to convert, we need to know relationships. And if you take a look right here, digoxin 0.05 milligrams per milliliter, that's actually a relationship. When it says per milliliter, it's actually for every 1 milliliter. So 0.05 milligrams of this drug is equal to 1 milliliter of this drug. Right? So if you measure out 1 milliliter of this drug, we know that there's 0.05 milligrams of it. Okay, how do we actually solve this? Well, we're always going to start with something. Remember how it looks like a small square, and then there's like these domino pieces, right? What are we starting with here? Well, it's actually going to be this 0.5 milligram dose. Okay? 0.5 milligrams. And the question is asking us, well, how many milliliters of this drug do we need to actually pour out? Well, anytime you need to convert, draw a time sign and then draw a line. The unit that should go on the bottom is always going to be the unit that we started with. So it's going to be milligrams. And I actually don't want you to write any numbers until both the units are complete. The unit on top is usually what you want to convert to. Now, we're trying to convert to milliliters. So I'm going to write milliliters up here, but is there a relationship that involves milligrams and milliliters? Well, yeah, there is. We actually just wrote it right here. Right? 0.05 milligrams is equal to 1 milliliter. So we actually write those numbers next to the appropriate unit. Again, 0.05 milligrams. So that number goes next to milligrams. And then there's 1 milliliter. So the 1 needs to go next to milliliters. And as you see here, this piece of information is just a relationship written as a fraction. The unit that does cancel out here is milligrams and milligrams though. We're left with milliliters, and that's what the question's asking for, right? How many milliliters? And since that's the unit that we want, we can write our equal sign. All we gotta do is punch this in a calculator. And if you did have a calculator, you'd know that we're starting with 0.5. And since this next number is on the bottom, you divide by that number. So pulling up a calculator real quick, we would see 0.5 divided by 0.05 gives us 10. Okay, the answer to this question is 10. 10 what though? 10 milliliters, because that's the only unit that we did not cancel out. Okay, so that means, hey, this drug right here, we need to pour out 10 milliliters of it to give to the patient. Now, a relationship is it's two. It's two quantities that are equal to each other. We have a relationship right here, right? Two quantities that are equal to each other. And we know a bunch of relationships. For example, something like 4 quarters equals $1. We all know that relationship. We know it so well that we don't even need to write it out. But it's a good idea to write out relationships when we're doing problems, because we may not be very comfortable with the units that we're working with later. So let's just get in the habit of doing it now. Relationships are also called equalities because there is an equal sign. Something equals something. Now, a conversion factor is a relationship written as a fraction that you multiply by in order to do unit conversions. We have a conversion factor right here. So I'm going to label that conversion factor in a different color. Okay. We've done different problems where there actually is more than one conversion factor, right? It can be 2, it can be 3, it can be even 4. This problem only needs one conversion factor that you would multiply by to solve the problem. It really just depends on what kind of problem you're looking at. Okay, there's a check for understanding here. You can try this problem if you want on your own, so pause the video. I'm going to show you how to get the answer now. So in this particular problem, we know that we have to write a relationship down. That would be very helpful. And the relationship that we can get from this problem is right here. 2 classes equals 61 students. There it is. Now, we're starting with 8 classes here, right? That's the quantity that we want to write down first. But we want to know, like, how many students there is in 8 classes. What do we do to convert these classes to students? Anytime you're trying to do a conversion, draw a time sign, then draw a line. I'm going to ask a question here. What unit goes down here? Hopefully, you said classes, right? It's got to be the same unit that you started with. The unit that goes on top is normally what we want to convert to. The question wants us to solve for students, so I'm going to write students here. Now, sometimes you might not be able to find a relationship that goes, directly from classes to students or directly from like centimeters to say inches, right? So that just means that you would look for multiple relationships. But do we have a relationship here that can go directly from classes to students? Yes, it's right here. 2 classes equals 61 students. Okay, well, where do I put the 2? Well, it's 2 classes, right? So I put the 2 next to classes. Where do I put 61? Well, it's got to be next to students, so I put 61 next to students. The unit that cancels out here is classes and classes. We're left with students. That's what the question is asking for. So I can write my equal sign and do this in a calculator. So in a calculator, we know that we are starting with 8. There's a 61 on top, so you multiply by 61, but since the 2 is on the bottom, you would divide by 2. Okay? So starting with 8, we're multiplying by 61, and we're dividing by 2. That gives us 284. Let me double check this. 8 times 61 divided by 2, 244. Let me just triple check this. 8 times 61, 61, divided by 2 equal, okay, it showed up twice here. Sometimes you just gotta double check or triple check. So we have 244. 244 what? 244 students, right? And that's what the question's asking for, so we know that this is probably a appropriate answer. We're gonna start looking at different units, and there are gonna be units that have prefixes. Okay, we already know about grams, we know about liters, and we know about meters, but sometimes we can actually put a prefix in front of it to change the meaning slightly, making it bigger or making it smaller. It says right here that there are many unit prefix tables. You can actually just Google it. They look different, but the information is the same. We're going to be using a table that looks like this one. And right here, when you're taking a look at it, it says common prefixes used with SI units. SI units are things like, again, grams, liters, meters. Okay, those are base units. Now, if we add something like DA, H, K, M, capital M, or capital G, when we add these prefixes in front of a base unit, it changes the meaning. For example, grams. Well, that's just a gram, right? If we put a K in front of it, that's a prefix. Now it's kilograms. Kilograms is different from grams. It's actually a lot bigger. And if you're wondering, hey, how much bigger? It's right here. Kilo. Kilo. Oh, it's 1,000. 1 kilogram is 1,000 grams. And we have these units or prefixes down here. These ones make it smaller. So if we're thinking about like milli, and we're still staying with grams, right? Base unit grams. If we add the prefix milli, which is a lowercase m, how is that different than the gram? Well, a milligram is actually 0.001 grams, so it's a lot smaller. It's like 1,000 times smaller. Okay, so what I want you to do is, if you need to, pause the video, recognize these and their symbols. You need to know what, like, each of these symbols, how to read them. Capital G is giga, capital M is mega, lowercase k is kilo, right? Also recognize these ones right here. These ones make it smaller, but make sure you know that, hey, C is centi, lowercase m is milli. This interesting one right here, it looks like a U with a tail in the front. This one's micro. Okay. Let's see. And then try to just be familiar. Hey, you know, all the ones that are these ones right here, they make them bigger. And all the ones that are down here, they make them smaller. Okay. And if you don't have a prefix, then you're just a base unit. Again, base units are grams, liters, and meters. Don't worry about the order of magnitude. All this is whatever the meaning is in terms of like exponents. So for example, like 10 to the second power is the same thing as 100. Okay, it's just a condensed way to write the meaning. Okay, right here, example 1, what's the relationship between what is this? Meters. Since it doesn't have a prefix, it's just a base unit, meters. This one has a prefix, micrometers. So what's the relationship between meters and micrometers? Well, you just look for wherever the prefix is on the table. Here it is right here. Micro, right? What's the relationship between meters and micrometers? Well, micrometer is this many meters. To visualize it better, you can kind of like imagine these M's. Micro what? Micrometer. The meaning is 0.000001 what? 0.000001 meters. Okay, so we can write a 1 in front of micrometer and an equal sign between these two different units now. 1 micrometer equals 0.000001 meters. That's the relationship, and I'm going to write that right here. 1 micrometer is equal to 0.000001 meters. Makes sense because a micrometer sounds small, so you should have a very small amount of meters, right? Let's do the same thing right here. What's the relationship between hectograms and grams? Well, the prefix here is hecto, right? Hecto. We're going to find hecto in the prefix table right here, unit prefix table. Where's, oh, here it is. Hecto. Okay. Hecto is H. It means 100. So we're talking about hectogram here. Hectogram. Hectogram equals 100 grams. And again, to visualize it, you can imagine hectogram, 100 grams. You can write a 1 in front of hectogram, put an equal sign between these two different units. Okay, 1 hectogram equals 100 grams. I can write that down. 1 hectogram equals 100 grams. Alright, so that's the relationship. Now remember, relationship is basically two quantities that are equal to each other. And this is what we have, two quantities that are equal to each other. That's how you show a relationship. On this next slide, this is just a check for understanding. Pause the video, see if you can do or write these relationships. I'm going to go over the answers right now. Kiloliter and liter. Kilo is right here. Right? 1 kiloliter equals how many? 1,000 liters. Okay, second question, byte and megabyte. Prefix is megabyte, or sorry, prefix is mega. And we look for the prefix on the table. Mega is right here. Oh, okay. Megabyte. 1 megabyte is how many bytes? This many bytes, right? So 1 megabyte is equal to 1 million bytes. There it is. 1 megabyte equals 1 million bytes. Question number 3. Grams, and this one is decigrams. Try not to get it confused with decagrams, because deca is actually DA. So grams and decigrams. The prefix here is deci. So we're looking at this. Decigrams is how many grams? 0.1 grams. And again, to be more visual, we can just put the G right here. Decigrams, 0.1 grams. You can put 1 in front of decigrams and put it equal between these two quantities. 1 decigram equals 0.1 grams. There it is. Last one. Micrometer and meter. Micro is the prefix here, so we're going to look for micro. Oh, it's down here. Micro is the one that looks like a U. So micrometer is how many meters? That many meters. 0.000001 meters, right? So to visualize this, micrometer is 0.000001 meters. Put the 1 in front of the prefix. Write an equal sign. 1 micrometer equals 0.000001 meters. I do want you to notice that basically anytime you have a prefix, when you're writing the relationship, the number is going to be 1. Look at this. 1 kiloliter, 1 megabyte, 1 decigram, 1 micrometer, right? Just put a 1 in front of it. And then the number, the meaning, goes in front of the unit that's just a base unit. But put a 1 in front of the unit that's a prefix. Okay? Alright, we can get to our third objective here, to use dimensional analysis to convert between units with prefixes. So here's 2 different examples, and they're slightly different from each other. The first example is asking how many millimeters are there in 0.67 meters. I do want you to notice in this one that milli is the only prefix here. So that's actually a hint. You need only 1 conversion factor to solve this problem. But I do want to write the relationship to help us out. So let's write the relationship right here maybe. And again, you only need 1 because the only prefix I see in this question is milli, right? Millimeters, milli. And if we're looking down here, milli is right here. What's the relationship between millimeters and meters? Well, let's see, 1 millimeter is equal to 0.001 meters. Got it? So I'm going to write that down. 1 millimeter is equal to 0.001 meters. Great. Now I can do the conversion. I'm going to start by writing the quantity that is in the problem, which is this one right here, 0.67 meters. I'm trying to convert to millimeters, so I have to draw a time sign and draw a line. The unit that goes on the bottom is going to be the unit that I started with, which is meters. I am trying to convert to millimeters, so let's see if I can write millimeters up here. Okay, do I have a relationship that goes can go between meters and millimeters? I do. It's right here. It says 0.001 meters is 1 millimeter. So I know where to put the numbers here. I'll put 0.001 next to meters, and I'll put 1 next to millimeters. Notice I left a space for the numbers. Always do the units first, and then do the numbers later. The unit that cancels out here is meters and meters. We're left with millimeters, and that's what the question's asking for, right? How many millimeters? That means I can write my equal sign, and I can do this calculation. Now, in the calculator, I'm starting with 0.67, and since there's a number on the bottom, I divide by 0.001. Now, I'm already expecting this to be a big number, because anytime you divide by a small number, you should actually end up with a big number. Let's see. So 0.67, I'm going to divide by 0.001. Oh, I ended up with a big number. Good. That's what I expected. 670, and then the unit is millimeters, because that's the only thing that's left that was not crossed out. That's the answer for this one. Example 4. Really similar. Let's take a look at this. It says convert 58,000 milligrams to kilograms. Now the thing that's different about this one is I actually see two prefixes. What? Yeah, you see it? Milli and kilo. Two prefixes. Milli and kilo, right? So what does that mean? That means I actually have to use two relationships to solve this problem. Now, the one involving milli, let's start with that first. Milli, milligrams. I know that I can write the relationship milligrams and grams. That's how you read these tables, right? So 1 milligram equals 0.001 grams. That's one of the relationships. 1 milligram equals 0.001 grams. And the other relationship is involving kilograms, right? So I'm looking at kilo. Do the same thing. 1 kilogram is equal to 1,000 grams. That's the second relationship we need here. So I'm going to write both of these down. Again, you might be wondering why? Why do I have to write this down? It's so it can help you out. Okay, the first one was milli. So 1 milligram is equal to 0.001 grams. And also the second one is 1 kilogram is equal to 1,000 grams, right? Okay, again, two prefixes, two relationships will be required. Okay, let's start this problem by writing what we're starting with. We're starting with 58,000 milligrams. There it is. I'm trying to convert to kilograms. Now, times, draw a line, right? And the unit that I'm starting with is going to be what? Oh, it's going to be milligrams, right? Same thing as before. Now, what am I converting to? Well, I'm trying to convert to kilograms, right? Now, this is the wrong thing. I'm going to write kilograms up here, but I'm going to notice, hey, milligrams and kilograms, is there a relationship that can convert between milligrams and kilograms? Well, this first one right here, up here, this one converts between milligrams and grams, and the second one converts between kilograms and grams. So no, there is no relationship that can directly go from milligrams to kilograms. So what do? I don't write kilograms up here, but just like the domino things that we were playing with, right? The conversion factor cards, we can actually convert from milligrams to grams first, and then go from grams to kilograms, right? This is just going to require two conversion factors. So again, this relationship can be used to help us convert from milligrams to grams first. So I'm going to put grams up here, okay? And then I'm going to put in the numbers later. I'm going to draw a times. I'm going to draw a line. Down here, I know it has to be grams. Okay, we basically write the same unit down to the bottom. And then I can get from grams to kilograms with the second relationship, right? Grams to kilograms. So I'm going to write kilograms up here. So notice I just pre-filled in the units. The units are taken care of. I can just write in the numbers now. And remember, this first conversion factor has numbers from this relationship. 1 milligram is 0.001 grams. Again, 1 milligram. That's why I put 1 next to milligrams. 0.001 grams. That's why I put that number next to grams. And then I can also look at the second conversion factor. This one has grams and kilograms. It's going to get numbers from this relationship. 1 kilogram is 1,000 grams. 1 kilogram, so I put 1 in front of kilograms. I'm going to put 1,000 in front of grams. There it is. What units cancel out? Milligrams, milligrams, grams, grams. We're left with kilograms. And that's what the question is asking for, right? Convert to kilograms. Great. So I can write in our equal sign. I'm going to write it a little bit lower. And for this particular problem, what are we doing? Okay. Well, we're starting with 58,000. We're going to multiply by 0.001. And then since this number is on the bottom, you would divide by 1,000. Let's see what we end up with. I got 0.058. Okay? 0.05. And then 0.058, what? Kilograms. This sort of makes sense because if you multiply by a small number, right? If you multiply by a small number, it should make it smaller. And then if you divide by a big number, it should make it even smaller. We have a pretty small number here. Also, this kind of makes sense because we're starting with milligrams. Milligrams, like we have a lot of milligrams. How many kilograms is it? Kilograms are big units, so you shouldn't have that many kilograms. Okay, hopefully that was helpful. And there's a little tip right here. When doing conversions of units with prefixes, you may need 1 or 2 conversion factors. Depends on how many prefixes there are in the problem. Just to emphasize this one last time, there was 1 prefix in the first example up here, example 3, right? If there's only 1 prefix, well, you only need 1 conversion factor, 1 relationship. In the second example, example 4, there was 2 prefixes, milli and kilo. What that means is we needed 2 conversion factors, right? 2 relationships. Here we have 2 check for understanding questions. I do want you to pause the video and try this on your own, and then unpause and see if you got it right. Okay, but I'm going to walk through it right now. Okay, assuming you're looking at your notes, you can find the relationships. But this first problem, we have only 1 prefix, micro. I know that 1 microliter is equal to 0.000001 liters. That's the relationship, and I can just get that from the table, right? That's it. We should only require 1 relationship here. There's only 1 prefix. We're going to start with this gigantic number, 50 million. And 50 million microliters. That's the symbol that looks like a weird U, right? We're trying to convert, so times, draw a line. What unit goes on the bottom? Well, that's a really long line. What unit goes on the bottom right here? Well, it's going to be microliters, right? It's got to be the same unit. What unit can we write on the top? Well, let's try liters. That's what we want to convert to. Is there a relationship between microliters and liters? Yes, I just wrote it down right here. For every 1 microliter, there is 0.000001 liters. Okay? The unit that cancels out is microliters. Microliters, we're left with liters. What do we do in this problem? We're going to start with 50 million, and then we're going to multiply by this decimal number right here. Let's try this out. 50 million times 0.000001 equals 50. Makes sense, because if you multiply by a decimal number, you should get a smaller number. 50. And then the unit, of course, is liters. And that's what the question's asking for. How many liters? Well, we have the right unit, so we know. We know this is probably right. Let's take a look at the next one. Convert 0.28, what is this? Hectograms to centigrams. I'm noticing right away, hey, this has 2 prefixes, so I need 2 relationships. Hopefully you got a chance to try to peek at the unit prefix table. 1 hectogram is how many grams? 100 grams, I believe. And 1 centigram is how many grams? 0.01 grams, I believe. I do have to double check this one. Let me peek. Oh yeah, okay. Whew, I got it right. 1 hectogram equals 100 grams, 1 centigram equals 0.01 grams. Again, I have two prefixes, I need two relationships. So let's solve this now. I'm starting with 0.28 hectograms. I need to multiply by something, a conversion factor, to do this conversion. I know that my unit on the bottom has to be hectograms. And the unit on top, what do I convert to? Well, you can try putting centigrams right now, but there is no relationship that can get you directly from hectograms to centigrams. It's split into two different relationships, which is hinting that, hey, we need two different conversion factors, right? So if you want to pre-write the second conversion factor, you can do that. But in the first conversion factor, hectograms can convert to what? Well, according to this relationship, we can convert from hectograms to grams. So I'm going to write G up here. Okay, I'm going to do this one a little bit differently before. I'm going to write the numbers in right now. How many hectograms and how many grams? According to the relationship, 1 hectogram, 100 grams. Right? I'm going to cross out the unit, hectograms, hectograms. We're left with grams, but the question is asking us to convert to centigrams. So we're not going to stop. We're going to continue going. What unit goes on the bottom right here? Well, it's going to be what's left. Grams. It's always going to be whatever was previous and on top. Grams goes on the bottom. And what am I trying to convert to? Well, I can convert from grams to centigrams, right? That's what our goal is, to convert to centigrams. And is there an actual relationship that can go from grams and centigrams? Yes, there is. 1 centigram is 0.01 grams. 1 centigram is 0.01 grams. Excellent. The unit that cancels out is grams and grams. We're left with centigrams. So since that's the unit that we need to convert to, we can write our equal sign. Now in this problem, we're starting with 0.28. We are going to multiply by 100, but we're going to divide by 0.01. I'm already expecting our number to be kind of big, because we are multiplying by a big number, and we're dividing by a small number. If you multiply by a big number, it gets bigger. If you divide by a small number, it should get bigger as well. Okay, so here we go. Let's check this in the calculator. 0.28 times 100 divided by 0.01 equals, a big number, 2,800. And then 2,800 what? 2,800 centigrams. There it is. Okay, I hope you found this video helpful.